Hello, Dr. Rauscher here. Got another problem to work on. When 133.0 grams of a compound decomposes, it forms 88.39 grams of copper and 44.61 grams of sulfur. Okay, so what we have is some compound that's composed of copper, and we'll just put a subscript of X here, and sulfur, put a subscript of Y, and when it decomposes, it's going to make X of copper plus Y of sulfur, right? That's just a generic looking reaction equation. But the question's asking us, when 5.264 times 10 to the third kilograms of this compound decomposes, how many grams of each element would you expect to recover? Well, what we're going to have to do is we're going to have to figure out what the percent mass is of each of these elements. Okay, so the mass percent is defined as being the mass of the element divided by the mass of the compound times 100%. Okay, so in this case, if we think about the mass percent of, say, copper, okay, the mass percent of copper in this compound would be the mass of copper. Well, in the first case, it looks like it formed 88.39 grams of copper. And that copper came from 133 grams of sample. Okay, multiply this by 100, and what we get is 66.46% copper, right? And so this compound turns out that 66.46% of the mass of this compound is actually from copper, right? Another thing that I could talk about here is we could just take 100% and subtract the 66.46 from 100, and that would tell us the percent of sulfur, or we can just calculate it like we did for the copper. And so we found out that we can make 44.61 grams of sulfur. Divide that by the 133.0 grams times 100, and we would get 33.54. Okay. All right. So now what do we do with that? Well, what we can do now is, if we want to know what the mass is in this other sample, so we have this sample that is 5.246 5.246 times 10 to the third kilograms. We want to know what the mass in grams is, then we can do this calculation. Okay, so the mass of copper, and we want it in grams. This is going to be equal to the mass of the sample, so 5.264 times 10 to the third kilograms. Now let's convert this then to grams. This would be 10 to the third grams for every kilogram, right? And now we just multiply this by 66.46%. And the answer here, when I did it on my calculator, I got 3.494584544 times 10 to the 6 grams of copper. All right, well, obviously that's more sig figs than we can have. This number here is an exact number, so it does not limit our sig figs. This one, not an exact number, but let's come back to this. So we have 4 sig figs here, and those 4 sig figs came from, well, we had 4 sig figs here, 4 sig figs there, so that is okay. That is 4 sig figs. And this one has 4 sig figs, so that means we have 4 sig figs. Are we going to round this up or down? Well, this is a 4, so that means we're not going to round this at all. We're just going to leave it as it is. And so this answer here should be 3.498 times 10 to the 6, and don't forget that part, grams of copper. So that's the answer to that one. The mass of sulfur, that is a terrible S, but well, there you go. So 5.264 10 to the third kilograms times 10 to the third grams per kilogram. By the way, this should be a small k. And we multiplied them by 33.54%. And what we get here is 1.7655. I went to 5 sig figs here so that I could round my last digit. Really, we know we only have 4 sig figs, so this should be 1.766 times 10 to the 6 grams. Now, what I want to say here also is some people think that what they should do is they should round this one from this. So that was a 5 there. Maybe this makes this a 5. And then that means that we would round this one up to a 9. But you can't do that. You don't do consecutive rounding. You only use this. These numbers here are completely insignificant. In fact, this number is insignificant. It doesn't even matter at all. But if we never rounded, well then, since there's some uncertainty in this, and that uncertainty lies in this digit, we can randomly round up, sometimes round down the other times, by choosing to round up whenever it's 5 or greater, and choosing not to round when it's less than 5. Since this number is irrelevant, we just will use that number to decide whether we're going to round up or not on this digit here. All right, I hope that was helpful.